Hi everyone, welcome to today's learning. So today we are going to talk about descriptive statistics. So in the previous video we have discussed on the definition of descriptive statistics and inferential statistics. So today we are going in detail about descriptive statistics. So what is descriptive statistics and what are the types of descriptive statistics? So descriptive statistics helps to define or summarize the features of the sample data. Let's say we have a data set and we have the multiple features. So if we want to know how the data or each observation is spread out in that particular data set, we'll use some statistical analysis, and that particular branch of statistics is called descriptive statistics. So what are the characteristics of descriptive statistics? There are mainly three characteristics of the descriptive statistics: measures of central tendency, variability or dispersion, and the distribution of data. So let's go one by one. So measures of central tendency. It's a single value that describes a set of data by identifying the central position within that particular set of data. So which helps us to analyze how the data means which may be average of that particular observation, or it may be a median, mode, or an outlier, anything. Let's say in a data set we have multiple features or observations. So if we take up one observation and if we want to find out which is the maximum value present in that particular observation, so we can apply like statistical methods like mean, median, mode. We can identify the value of that particular observation. So we can analyze and we can take some decision on that particular observation. So mainly we have defined four types of measures of central tendency here. So the first one is mean or mean, median, mode, and outlier. So mean, I think everyone know about mean, like it's an average, nothing but an average. It's the sum of all observations divided by the number of observations. So using Python we can calculate using data.mean function. And trim mean is nothing but an average, but we have ignored the highest and lowest observation. The main disadvantage of mean is it will be affected by the outliers or missing values. If that particular observation having multiple missing values, then the value that we got, like the mean value that we got, may be not effective for our model building. So the next comes with median. So median is the middle observation in the data. So basically when we sort that particular observation in ascending or descending order, so we can take up the middle value and it will be a median value. So let's say if the observation having even number of values, then we have to take the two values, the middle two values, and we have to take the average of those two values, and it will become median. So this can be calculated using data.median function in Python. And the next one is mode. So mode is the most frequent observation. In an observation, let's say if one particular value is repeated multiple times, then we can consider it as a mode value. So mode can be applied for both numerical and categorical values. And next comes the outlier. In a data set, in a particular feature or observation, if we take all the values, few of the values might be differ from the actual values. The difference between the actual values and one two values will be a huge. So that data points will become outliers, which may act significantly for our analysis. So sometimes we have to take action on those particular data points. So outlier is an important topic in machine learning or data. So these things will be discussed in detail in the upcoming videos. So the next type of descriptive statistics is a variability or dispersion. Variability refers to how the data is spread out. Using this, we'll get to know whether data lies close or far from the central tendency. The main measures of variability are range, interquartile range, variance, standard deviation, z-score. So we'll see the one by one. So the first one is the range. Range is the difference between smallest and largest value in an observation. but it is highly affected by the outliers. If the outliers are present in the data, then the range is not suitable measure. So the next one is interquartile range. So interquartile range is the range in which the middle 50% of the data considered. The IKEA can be called as mid-spread or middle 50%. It is defined as the difference between 75th and 25th percentile of the data. So IKR can be calculated by taking the third quartile and the first quartile data and taking the difference between third quartile and the first quartile. So we'll get the IKR value. For getting the middle 50% of the data, or generally in statistics speaking, we have to take the data 3 times of IKR. So this will be discussed in detail in the future videos. And the next comes variance. So variance helps to identify how the data is spread out. If the variance is more, then the data is more spread out more. We can calculate it. The variance can be calculated using arithmetic mean. And similarly, the square root of variance is nothing but standard deviation. And z-score tells how the value is away from the mean. Let's say in an observation, each value will be having a z-score. So if you want to analyze one particular data point, we can check how far this particular data point from the mean. So we will get to know using the z-score. So we can calculate z-score by subtracting the mean and divide it by the standard deviation. So next comes the third type of descriptive statistics, that is distribution of data. So distribution can be analyzed using matplotlib or Seaborn graphs. So we can see the skewness, kurtosis, covariance, correlation between the multiple observations, and we can analyze each observation or the multiple observations. So distribution of data helps to make some statistical decisions. Let's say if we plot any one of the observations and the maximum values are spread out to one particular side or one particular region, whether it will be right side or left side. So that particular observation will be having a skewness. It may be positive or it may be negative. If the extreme values are larger and which increases the mean value, so which can be called as positively skewed or right tailed, means the right side it will be having more larger values. So in that case, mean will be more than median and median will be more than low. If the extreme values are smaller, which decreases the mean value, and we can call it as negatively skewed or left tailed, and most of the observation will be lying in the left side of the plot. So skewness and kurtosis will go in detail in the next videos. The kurtosis will be, it can be measured using the peakness of the distribution. Basically, it tells about the peakness of the distribution. And the next one is covariance. Covariance can be applied between two variables. So it's a measure of relationship between two random variables and how actually they change together. So this can be calculated using the covariance. And correlation can be applied for all the observation or any of the two observations, so that which basically indicates the extent to which the two variables increase or decrease in parallel. So some of the distribution statistics characteristics can be explained in the next videos, or during the learning process you will come through all these things, so you will learn more. So this is for today's guys. Thank you so much for watching the video.